So, hi everyone, I'm Vlad, and I'm a postdoc at the Language Technology Group. So today, as mentioned, I will be talking about benchmarking Norwegian language models, and also our new evaluation suite, which is called Norwegian. So about our group, so we have been working in several directions regarding the large language models. So they also consider pre-training, so we also develop pre-training corpora as part of the HPLT project, which is funded by the EU. And also we have been developing lots of language models of different architecture. So it's ranging from standard BERT architecture to Mistral-based language models. And then for post-training, we have been working, like most of the work is in progress, but because it's like a super difficult topic nowadays, I think, and also in the context of Norwegian. And but we still have some open source stuff, so you can check out one of our models, but it's not the best. So, and regarding benchmarking, we have also been developing benchmarks for standard NLP tasks, which is called NurBench, and also the recent one, which is called Norval. So this will be the main topic of this talk. So let's talk about the language models. So now we have a lot of language models for different languages, and there's just an explosion, and this picture is very old, I think. People are just lazy to make a new one, because especially post-trained language models also consider the large amount of the available options. And the main question arises, like how I select language models for my task or for my specific user case. So what can I do, and like what I want to measure. And in the field of NLP, benchmarking has been established as a standard approach to comparing different language models, so we can have different evaluative criteria or also a combination of these criteria. And it's very important since it promotes systematic and also objective evaluation. Generally, as also has been mentioned in the previous talk, so how a benchmark can look. So this is like a collection of tasks. Each task has a task-specific performance metric, and then we somehow want to aggregate all this stuff into an overall score, by which we want to decide which model is better. And usually benchmark holders provide public leaderboards, where these models, if it's possible, compared against each other and also humans. And there are a lot of also main benchmarking directions, so it's not the whole list, but it's just, the main one that I think also relevant for this talk. So it's like intrinsic evaluation. We can just ask a language model to predict some word and also estimate the probability of a text. And then the next direction evaluates how good a model encodes a sentence or a text. So this is mostly relevant for information retrieval or like for the industrial tasks when we want to solve specific user cases. And then we have language understanding. So this is also, like, I think first it arises for more linguistic tasks, and nowadays it's more complex tasks such as multiple choice QA, like common sense reasoning and stuff like that. And then the most difficult one and the most relevant nowadays is the language generation. So it's super difficult to evaluate, although I think nowadays people mostly use generative language models. And here, like, we just want to solve a particular task by just producing a human-like text. And then the last one, and the not least, so it's also fairness, or we can also say that it's safety and also ethical evaluation and also harmfulness. And this is here we want to just try to evaluate how good, or like how good the model is in terms of not reproducing biases and also some stereotypes from the pre-training or post-training data. And just to give you an overview of the well-established benchmarks for English, so we have, it's very popular, the MMLU benchmark. So it tests the language model knowledge across different difficult topics. I think I'm not able to answer this kind of stuff because it's, it can be medicine and also law and stuff like that. And it's also US specific. And its recent version also extends the number of options from 4 to 10. And the other one, so it's just also to give an overview, it's just also regarding the evaluating generative capabilities. So here we nowadays have also humans and also language models that can evaluate the outputs of the other models, and then we just try to compare which one is better in the pairwise manner. So what's happening with Norwegian? So there have been 4, and now it's 5, benchmarks which have been developed as part of the medium-scale efforts and also more like Scandinavian evaluation initiatives. So this cover some standard NLP tasks, which is NordBench and also Scandival. And also the SEB benchmark evaluates how good the model encodes the text. And the most recent one, the NLE bench, it's mostly related to evaluation of generative capabilities. But these benchmarks have several shortcomings. So the first one is task coverage. This means that there haven't been many attempts to create new data. So this means that also data sets are being reused in different settings, and yeah, it's just a lack of new task formulations. And also some of the benchmarks introduce machine-translated data, or data that's first been generated and then part of it was validated by humans. This also raises data quality concerns, and I'll talk about it more a bit later. And regarding linguistic diversity, we also have low coverage of Nynorsk, as you can see from the table. So it's also, I think, related more to super standard NLP tasks such as machine translation, and also not that many attempts has been to increase the representation of Nynorsk. And then we also have human baselines, which I mentioned that they are used for establishing the upper performance bounds so that we can try to compare how good model is, referring to the how good humans are at this task. And yeah, over the last few years, we have been at L2G, also with collaboration with the National Library, we have been developing 17 data sets. So it's, yeah, basically we try to adapt standard English benchmarks and data sets through manual translation by Norwegian native speakers, and also paying a lot of attention to localization, because many data sets are US specific, and also dedicated effort to create the Norwegian data from scratch. So all our annotators were able to do that. And so what is Norval? So nowadays it's the largest benchmark for Norwegian, which covers both Bokmål and Nynorsk, and also includes 24 data sets. And then we should mention that it has been developed from the Mimir project, so this was the collaboration also between National Library, NTNU, and our group, also led by the National Library. So here is, this project was devoted to evaluating the goal of the copyrighted material on pre-training language models. And then also Nurival have been recently used for also comparing different pre-training corpus for large language models, so which kind of data is better to pre-train language models for Norwegian. And one of the distinctive features of our benchmark is that we have a lot of prompts. So all the prompts are written by Norwegian native speakers, and this allows to conduct robust evaluation. So this main reason behind doing this is that the models are super sensitive to how we formulate a task, and they can just give a very low score if you just are not super lucky with formulating what we want from it. And then we also establish human baselines on our new datasets. So just to also give you an overview, so we have 9 task categories, so they range also from standard text classification to more recent and more relevant task categories, which include like instruction following, and also I think the cat sign means that the benchmarks have been used in the previous benchmarks, and you can see that all the rest are new. And regarding some of the examples, I'm not good at Norwegian, but you can read it, and I think some of the, and if you want, I can also show more examples later, but this is also to show that we have different scopes of asking the models to do various stuff. And what is behind the main approaches for evaluating generative language models? So basically, this is called in-context learning evaluation, or also few-shot evaluation. So the main idea that we just take the model as it is. We do not train it on any train set, and we can just evaluate it on the test set, but we can also use examples from the train to show the models how it should perform the task. So this is shown in the slide. So for example, we can show two examples from the test from the train set with the gold labels, and so this is the model should generalize to this task, and also we expect to answer it also the correct way. So this is also, this is the few-shot evaluation, and we can show different numbers of examples as part of the input. And there are two main strategies of how we produce the prediction. So the first one is scoring or probability estimation. So here, for instance, we will estimate the probabilities of positive and negative class and just take the most probable one. And the next option is just to give the model the input and ask it to generate the answer. And these are also examples of the prompts for the sentiment analysis tasks. So we try to also diversify all the prompt formulations to make the model more help it to generalize to the task. And again, as I told that, the main problem is the prompt sensitivity. So we want to estimate the performance across all prompts and then somehow aggregate it to get the best results. And in our paper, also in this talk, I will mainly talk about the key results of evaluating 19 open source language models for Norwegian. And of course, it's also not an exhaustive list, and we lack the evaluation of proprietary models or API-based models. But we also make a special focus on the performance aggregation because it's also one of the open challenges in evaluating language models. So we have, usually in benchmarks, we have different tasks and they have different task performance metrics. So for instance, accuracy, blur, like correlation coefficients and stuff like that. And it's just different on scale and different nature of these metrics, and like simply averaging them is not the best idea. But people still do that. And here we also follow one of the most recent practices. So we try to normalize the score at the same scale by also subtracting the performance of the random guessing baseline. And we also try to build the rank-based aggregation, which means that, so this is also recent practices, so they are drawn from the social choice theory. So this kind of stuff used in deciding the winner of the elections or like some other things. And here, these kind of methods, they are not sensitive to any performance metrics. We just compute how many times one candidate outperforms the other. So it's just count-based procedure. And we compare the results of the language models on this novel data sets and human baseline. So here we have all the subsets of these data sets annotated by 3 annotators, and then we just take the majority vote. And we also present one of the first results of evaluating LLM as a judge for Norwegian. So it's not, although it's not perfect and it's just a lot of work also need to be done in this direction, we still try to use it as a complementary approach to evaluate generative language models. And then we also analyze different biases of this judge model. So we have a lot of things, and I will just focus on several of them, and you can read more about specific like evaluation directions and analysis in our paper. The link will also be available in the end of the slide. So here, first of all, there is no like single model that outperforms all the others on in many task categories. So this is, I should say that this is the aggregated results by task category that we have. And here the bluish colors means that the performance increase of the performance of the instruction-tuned model increased compared to the base model. And the warm colors indicate that the performance decreased. And usually LLMs perform well on certain task categories, so this include sentiment analysis and also machine translation. and they struggle with the novel tasks that are more require more like creative writing skills, which fall under the category of instruction following, and also novel question answering datasets. And it can be a bit like contradictory, but also there has been supported, these findings have been supported in many previous works for English and in many other languages. So when we post-train the model, we expect it to perform better, but it's not always the case. So somehow the performance can degrade on particular skills or particular task categories, and somehow it also increases. And we saw the improvements of the public available instruction tuned models on particular tasks. So this mainly refers to multiple choice QA and sequence to sequence. And then we also have task categories where performance significantly dropped. So we also performed the manual analysis of the generated outputs. So this is mainly the problems relate to, so the model can become very tipsy. So it's like, yeah, I can help you, and blah, blah, blah. And like performance metrics do not capture or like decrease the performance of such answers. And then we also have cases when the model maybe don't understand the language in the input prompt, and then just answers in English or Danish or Swedish. And yeah. And regarding the LLM as a judge evaluation results, so here we can see that we only evaluated 5 instruction-tuned models, and we're also working on evaluating them more. But here on these 2 data sets that require creative summarization and creative rewriting, we can see these 2 main winners, but also we observe the same issue as was seen in the manual analysis, that the models just switch to in other languages. That's why they can lose quite often. And now how we can just run our evaluation suite. So basically you need 2 steps. So the first one is to evaluate or to install the LLM evaluation harness. So this is a very popular framework nowadays, and it is was mainly designed for English, but now it includes benchmarks for many different languages. So then you should configure your evaluation case. So this can be an open source model from Hugging Face, or also API-based model from OpenAI or something else. And yeah, you just run one of the comments that you can read more in the documentation. And I want to conclude with open challenges. I think some of this will overlap with the previous talk, but anyway, maybe I will focus on this kind of issue a bit more. So basically what we have, what kind of outputs we deal with when we evaluate generative capabilities. So we usually have some prompt, and we have responses from several models. We also have human response, so this is kind of response that was written by an annotator, and this is how we want our model to perform, or which kind of output we expect from it. And then we just ask a question, how, or like which one is better. So there are 3 main directions of how we evaluate generative language models. So the first one is based on performance metrics. So this was mentioned also in the previous talk. And they do not capture the diversity of the possible outputs. So this means that when we have this human written response, it doesn't mean that it's the only one that is possible. Like if you want to summarize a text, there are a lot of many like versions of how we can possibly summarize it, and all of them can be correct. But this kind of metrics also poorly correlate with the human judgments on different criteria. So this means that like when we want to evaluate specific safety in the outputs, these metrics will not show the results of evaluating particular safety that we're interested in. And then we have the manual evaluation, or also human-based evaluation. So here we just ask a human to evaluate the outputs, or to compare the outputs, whatever we want. And of course, it's very reliable in a way, but it's super resource-consuming, which means that it requires a lot of money, a lot of time. And when we do development iterations, it's super time-consuming to deliver best results, or like quick also analysis of the changes that we made. And if we talk about crowdsourcing platforms, so there are also studies that run the same annotation setup several times during the month, and they get completely different results. Although like it's just different humans performing different evaluation. So it cannot be reproducible. And when we talk about the language model evaluation, or LLM as a judge, so as mentioned also in the previous talk, this suffers from various biases. So for example, some model can prefer a longer output, or if we switch the position of the outputs like A and B, the model will still prefer the first position, although there is a different answer and stuff like that. So, and in context of Norwegian, we, for now, have only the results of evaluating only one model, and there is still also a lot of work to do in this direction, but I still think it's very promising for less resourced languages such as Norwegian. And then we have the data contamination issue, which has also been mentioned in the previous talk. And this problem mainly can be formulated that our evaluation data appears either in the pre-training data or in the post-training data, or we also have an overlap of the in-domain and out-of-domain tasks. And the issue with this is very relevant nowadays, because we get a lot of models, and I think the models are being developed faster than creating new data sets. And then it's just, can get passed, but potential solutions, of course, is responsible development. So this means that we want the developers to transparently document which kind of pre-training corpus they used, and also conduct the data contamination evaluation. So there exist several methods for doing that. And also, at the same time, the benchmark developers should document which kind of resources they used, which sources from which kind of time period and stuff like that. So the next challenge, so this also relates to the data quality. So here, the main question is like how I create my benchmark, or how I create my data set if I want to evaluate a specific domain, or if I want to evaluate a specific task. So very, I think, appealing method is just to take an English benchmark and then translate it just to get some quick evaluation, because it, again, requires a lot of money, especially in the specific domains. But here the question is, so what we want to evaluate? Of course, it doesn't apply to all tasks, but here, for example, if we translate an example from MMLU, so the one that I showed to you earlier, we ask the question in Norwegian and also provide the answer options in Norwegian, but we still evaluate the US-specific context. So what we want to evaluate, if the model is aligned with the Norwegian language and the Norwegian culture and also Norwegian values, or if it can understand Norwegian but still answer about the US-specific stuff. And so this can also relate to questionable data quality, because of course the choice depends here on the machine translation model, or also on the model that we use to generate the data, but there are out now benchmarks that have been generated and just not validated, and people say like, you can use it, which is not good. And I'm also not against synthetic data generation. I also think it's very promising in case of Norwegian, especially for post-training. But if we do this for creating the evaluation data, we should thoroughly evaluate or validate the examples by humans. And especially the best one is 3 or 5 annotators for one example. And then maybe when we generate the data at scale, we should also design like data quality criteria that would help us to filter out really bad examples. And the last one, the main problem with Norwegian, I think, so which like kind of prevents us from developing open source language models for Norwegian that could be accessible for, or like be useful for the academia and also industry and the general public. I think the general public just uses ChatGPT. And this was, I think, creating post-training data and also creating evaluation data, because we still lack it. So now we have one more benchmark, but of course it's not the solution for all the problems that we have, and also increasing the representations of Nynorsk and Sami. So this is our less represented language variants, but we still have potential users that also want to use language technologies. And then we have the issue with the domain-specific evaluation where we just also lack the data resources for medicine or for law and also other disciplines. And I think that the potential solutions here that, yeah, we should try to collaborate because, yeah, it's the main, I think, faster way to get more resources and more models. And in the previous talk, it was mentioned that crowdsourcing can be useless, but I have to disagree. So if we design the annotation setup quite smart, so when we do several stages, when we first annotate, then validate, and maybe validate once again, so this could lead to high quality data. And also when we talk about data sharing platforms, so this exists for English when just the users donate their data, for example, with chat assistants, or just try to spend some time while drinking coffee, just annotate some examples and just, yeah, forget about it. So I think this can be potential solutions to get more resources and also more advanced language models for Norwegian. And this was it. So these are the links. First is our paper, which was presented in the conference, ACL conference in Vienna this year, and also to our GitHub repositories with all the documentation and materials. Thank you.
Yes, thank you. We have some few minutes if people have some questions. Any questions? Yes.
Sorry. Hi. First of all, tusen takk for your presentation. Very interesting. I was wondering if all these benchmarks are run in some of these models. You can set up a parameter, the temperature parameter. Are all of these benchmarks run with a fixed temperature like 0 on these models, since they are not always used like that?
So, for instance, in case of when we evaluated, so we just take the recommended hyperparameters from the Hugging Face model cards, and we do not experiment with the generating different hyperparameters because it's like a lot of models and a lot of tasks and also a lot of prompts. So we decided just to take the ones that are recommended by the model developers.
Okay, just a very brief question. I noticed you mentioned that in many tasks the model switched language.
Yeah.
Do you have any insight on how the performance is affected when it switches languages? I've seen that usually there's this bias in English, so many times the benchmarks look at the outcome, and to get to that outcome, it may switch language and get the correct outcome. Do you have any insight on how the results you got with this when it switched language?
So I think I cannot answer like when it specifically switched the language. I think it also depends on the input examples, but it's not always happening. It just happens in particular cases. And for instance, for the machine translation task, when we see the input in the English sentence, the model can switch to English. Just trying to first yes, I can help you with translating the sentence and then providing a translation in a target language. But we're just interested in evaluating the output. But we have a lot of stuff in the response, and that's why the performance metric is very low, because it has more tokens in the output. And also, I think this also relates to for instance, Swedish-based models, which also which are pre-trained on both Swedish and Norwegian data, and I think some models just switch somehow to between languages.
Thank you very much.
Yep.
Some else?
I saw that you mentioned that you have several data sets, but how large are these sets?
I think I don't have statistics here, but for the QA data sets, they all end with QA. so it's easy to navigate maybe. But I think it's more than 10,000 of question-answer pairs. And also, when we talk about the instruction following datasets of like creating creative summarization and rewriting, it's mostly 400 in total. Yeah. So I think some test sets can be like several hundreds to thousands. Yeah.
Yeah, and do you weight that in when you do your scores at the end? How large your set is?
No, when we aggregate, yeah. So if the dataset have some like subsets, for instance, different topics, we try to weight by the size of the topic or like subsets. And then, yeah, it's just the compound thing. And then we have the category, which relates to like, I don't know, Norwegian language knowledge. Then we also try to weight between this category, and we average within the category. And then to get the overall score, we average across the categories.
Yeah, and you also talked about summarization,
yeah.
and that you can have like infinite amount of versions of a summary.
Yeah.
Based on who's writing the summary,
yeah.
By human evaluation.
Yeah.
And do you have that in your data set as well, like representations of different summaries by human?
Yeah, so this is a good question, I think. So this NURSUM data set, so it's not large, but the main also advantage of it that we have several human written summaries. So it's 3 of them. And we compare against every summary and just also take the maximum performance score. But in case of this creative summarization, so here is non-summarized IT. So we, again, since can be plausible outputs and we didn't have much resources to conduct human-based evaluation, we tried to take a complementary approach by LLM as a judge. So this is try to avoid this kind of complexity.
And one last, it's about just the amount of data you have in your sets. Are there any initiatives at the university level where, because all the students are handing in summaries and text for different assignments throughout the course load in all subjects, right?
Yeah.
And those are there any initiatives to collect all that information and language information to make a super large Norwegian data set?
Yeah, this is also a really good question, because also when we tried to create new data sets, we were also looking for open source initiatives or like, trying to find different ways of also donating the data. So, for example, NRK quiz. So these are the series of quizzes from NRK. They have been contributed, and thanks a lot. But I think it also helps us target a Norwegian-specific evaluation. But regarding your question, I think it's important to try to find different ways. And I think, we are also working on this.
Thank you.
It's a good suggestion.